Hello, this is Robson from FLO-2D, and today I'm going to do this webinar on 3D animation, where we are going to create a 3D animation video of FLO-2D urban flood mapping. So this is an image, and I'm going to show you a video of what we expect to achieve by the end of this webinar here. So this is our self-help kit, where we have the buildings in 3D with different heights. We have some trees as a 3D object. We have some walls here. I think here on this channel is easier to see the walls. We also have the FLO-2D results as a raster, and then we have this whole animation here exported as an MP4. So this is an example. This is what I plan to do during this webinar today. Just going to move ahead here. Then we have another example uh, for our coastal project. So same thing, the only difference in this project is that we have the velocity vectors here showing the direction of the flow on the floodplain. Um, we also have different buildings height here. The color of the buildings are a little bit different. You can see what we can achieve using this QGIS 3D map view. It's a pretty nice feature to show your results to the public, to stakeholders. It's a nice tool for visualizing your FLO-2D results. Okay. We have other videos, but this is just to give you a general overview of what we want to accomplish today. Today is going to be a very hands-on webinar, so I'm not going to talk about theory because I just want to have um, this animation done by the end of the webinar. Okay, and so here are some of the requirements that we need to have. So this will be done using QGIS, and to get the buildings data, we are going to use the Quick OSM plugin. And to get the base map, we are going to use the Quick Map Services plugin. And for the FLO-2D results, we are going to use MapCrafter. MapCrafter here is optional because if you don't want to use a FLO-2D result, you just want to use to create the 3D animation you can do. This is just to show you what we really need. We need those two plugins and the FFmpeg, which I'm going to talk about in a second. This application is used to create the video. So what I have here, I hope you are seeing my QGIS. I have a blank QGIS here. By blank, I mean I created user profile here just for this webinar. So no plugins. This is what you are going to see when you install QGIS. So as I said, we need to install three plugins: the Quick OSM, Quick Map Services, and MapCrafter. So let's go to plugins. Let's wait to show the repository here. So just type Quick OSM, select this guy here, and install plugin. It's going to download the data. It's really fast. You can see this has a lot of downloads, so it's a very good plugin. The second plugin that we need to download is the Quick Map Services. This guy here, also very we have a lot of downloads on this plugin. Can close this. And the last one that we need to install is MapCrafter, which is also available on the QGIS repository. You can just click on install plugin. And then we have MapCrafter, Quick OSM, and Quick Map Services. Before I start, I would like to add some more base maps because default installation of Quick Map Services, we only have those two here. So just click on this icon, go to settings, and then go to more services, get contributed pack, and then we get all those base maps here. Google, Waze, ESRI. So we have a lot of base maps, okay? So we got the plugins. Now let's talk about the FFmpeg. So I'm going to open this. So basically is this application here. I'm not going to show you how to download and install this because it's going to take some time, but basically you just go here and download it. To install, I added this YouTube video here. So if you click here, it's going to get you into this. Oops, sorry, my bad. It's going to give you into this video on how to install FFmpeg on Windows if you are using Windows. It works on Linux and Mac as well. So it's going to 3 minutes video just showing you how to download and install the data. Okay, so we have QGIS, we have the plugins, we have FFmpeg. I'm going to use trees as 3D models. So if you click here, it's going to get you into the QGIS 3D models. So you can see that we have some apple tree, spruce log poly. We have also some mailbox, recycle container, street lights. You can add those into your 3D video if you want. I'm only going to use the this apple tree here because it requires some processing time to if you add a lot of 3D models. So I'm just going to show you how to do using one, and then you can replicate that or more if you want. We can have tree, cars, people, etc. You can download this from another source. I just use this one here. And extra detail, walls, fences, everything that you can digitize and add to your 3D animation. Something that is I recommend you to do is to add the GPU acceleration on your QGIS. So just open your QGIS, go to settings, options, and all the way down here to acceleration, select this one. And it's going to say that some of the internal C++ processing core algorithms and renderers can take advantage of OpenCL compatible device to increase the performance. Basically, it's going to use your GPU to improve the processing in general when doing 3D animations here. Click OK, and everything is set up. Okay, so let's go ahead here. So as I said, this is going to be a very hands-on webinar. So if you have any questions, please use the Zoom to ask those questions, and I'll be happy to answer them on the fly. So let's get started. Step by step. The first thing that we need to do is to create a QGIS project. So basically, just save this. I'm using this folder here where I have some data. I'm going to call this 3D project. Okay, so we have this 3D project open. The next step is to load the domain. So I have the folder here, project, and I have the computational domain here. I'm just going to drag and drop it into the layers here. I'm going to close this browser because I don't need that. And for those who are familiar, this is the computational domain for our self-help kit. So I'm just going to change the symbology here a little bit. Right click, properties, go to the symbology. I like to use this outline red, but I like to change this to a dashed line and reduce a little bit the stroke width to 0.5. Click OK. Next, we are going to add the Google satellite image. So let's use the quick map services, Google satellite. So here we go. So the animation is going to be created inside this computational domain here. Let's go ahead. Then we need to download the OSM data. For this, let's use this plugin here, the quick OSM. It's going to ask you if you want to read the copyrights, and I'm going to say that I understand the copyrights. And for those who are experienced with the quick OSM, you can use some queries here to get more specific data like agricultural data, bridge data, height, information, industrial land use. But we are not going to use this right now. I'm going to use a map preset that comes with the plugin, which is this Urban here. It has the buildings, and the buildings is what we want right now. So just click here to select the map preset. This is going to download the OSM data based on the layer extent of the computational domain, and click on Run Preset. Yesterday, when I was doing this, it just kept running this and it didn't download. And this is due to the API. So if you face something that it just don't download, just go to parameters here and change your overpass API to one of those fives here and click save and try again. You should get the data, okay? So it downloaded the database on the layer extent. So we have the road here. For now, we don't care about the road. I can remove this layer here. I really don't care about this. And then as you can see in the symbol here, it is a temporary scratch layer. So what I'm going to do, I'm going to save this on our project folder. The format is going to be the ESRI shapefile. I'm going to save this on my folder here, project, and I'm going to call this building. And I'm going to save as the same CRS that I'm using here, Arizona Central. Click OK, OK again, and here we have it. We can delete this temporary layer. So you can see that we have some buildings here that are on the layer extent, but we don't want to use those. So what we can do, we just can get, we can click on this select by location. This is a QGIS tool. Select features from the building layer that intersects the computational domain. So are those here. But I want the layers that are not within the computational domain. So I can click here on this arrow, invert feature selection, and then I have the layers that are not within the computational domain. I can click on edit here. You see that we have some here on the right here and all the beauties on the bottom. Then we can delete those 506 features. Then we can save the buildings, and that's okay. Those are the buildings that we are going to use to create our 3D animation. So after that, we need to set the buildings level. And this has nothing to do with the FLO-2D simulation. We are setting those building heights just to make a nice visualization where houses are lower than apartments, for instance, or something like that, just to create a nice visualization. Nothing to do with FLO-2D modeling, okay? So in order to do that, we just right-click on building here, open attribute table. Then let's take a look into this. So we have some IDs here that we don't care. We have this OSM type that we don't care, but we have this building field here. If we organize this, we can see that we have some apartments. If we go down, we have some carport. We have some commercial, some garages, greenhouses, house. What else we have here? Have a lot of houses. And at the end, we have some retail, public, roof, school, and some yes, which I have no idea what that means. Probably that we have a building there. But okay. And the other fields here, it's just a name. So some other information that you can get from OSM here. Okay. But what we are going to do here, we are going to estimate the level of those buildings. So to do that, we need to open the field calculator, create a new field, and I'm going to call this field building level. And this is going to be a decimal number. And what I'm going to do here, I'm going to write the following expression. Case when the building is equal to apartments, it must be equal, this must be four levels. That's something that I am assuming here. You can assume something different for your animation. When building is equal to hotel, then 3. When building is equal to commercial, I'm going to say that it has 2 levels. And when building is equal to house, then 1.5. Everything else is going to be 1. And then end. So you see that we have preview as 1. It means that this expression is correct. It's important to note that we must use this symbol here for the field and this one here for what has as a feature here. Okay, so this is really important. Then we have 3, 4, 2, and 1. We could add more if we want, like we could add like a retail or everything else. That's totally up to you. I'm going to use this because this is more for demonstration purposes. Let's click on OK here. Then we have the building level. See, apartments is 4. Then we have carport is 1. We have house, which is 1.5, and so on. Let's save this. Okay, we can close this. After that, create the 3D. Okay, so here's where we start building the 3D information. Right click, go to properties, click on 3D view here, single symbol. And the only thing that we are going to change here is the extrusion, which is going to be the building height. Click on this icon here, go to edit, and then building level times, I would say 8.5. This is in feet. 8, 8.5, 9. It's up to you. I'm going to use 8.5 here. Click OK. We don't need to change anything else here. If you want to change the color of the houses, you can change, but I'm going to keep this way right now. Click OK. Then let's take the first look at the 3D view. Just go to View, 3D Map Views, New 3D Map View. Click here, expand this, and then you can use your mouse, your rolling wheel here, and zoom. And then you can see that we have some different heights here for the buildings. Okay. I'm going to go back here. Something that I like to add is these edges here. I like it gives a nice effect. Like 2 pixels, color black, click OK. And then you see that we have this black edges here, and I really like that. Okay, so everything's looking good here. Let's see what we should do next. Okay, after that, we need to add some details to our 3D animation here. I'm going to start with the elevation. So I have 2 elevations here. So this one is the one that we used for the modeling, which means that we have more detail here. This one is larger, but it's not as precise as this one. And I'm going to talk about this later on. Is just to have more area on your 3D animation. Let's start with this guy here. Just drag and drop. Let's move this to the bottom. So if you click here again, it's a little bit buggy that happens. So you can just exit there and create a new one. That's totally okay. Expand, and then you can see that we have some elevation here. No, we don't have elevation yet. You need to click here and go to terrain, DEM and select the elevation and click OK. Yeah, now we do have some elevation here. You see, we have some small hills there. We have the channel here. We can also add some vertical scale here, like 2 if you want to have more. Oops, just lost it. Where is it? Okay, here. If you want to have like, let's say an exaggeration, but I will not use that because I don't like that too much. But you see that we have the canal here. Okay, let's get back to 1. So, and then elevation is done. So we added elevation to the project, okay? So what I was talking about elevation before is that it reads the extent of the elevation here. So that's why we have this area here. Let me just move this to the top so you can understand what I'm talking about. So this is going to be the extent of the animation here. If we want to use a larger area, you need to add a larger elevation file. By larger, I mean which is bigger than this one. But for now, let's stick with this one here. Let's move this to the bottom. What next? Walls. Okay. So let me zoom in here. So I have some walls where it was digitized. Just create, I'm not going to do this, but basically create a shape file and add some lines. So this is what walls mean. Okay, so walls. So they are purple here. So some walls here. We have more walls here. Here represents some fences. Okay. And they are not 3D yet. We need to follow the same approach that we did for the buildings. Right click on walls, go to properties, 3D view, single symbol. Then we have the width of the wall. I would say 1 is totally fine. Offset we don't use. And then extrusion, we can put like 4 feet, maybe 5 feet. Let's put 5 feet. I think it's okay, 5 feet. Click OK. And then if we go here, we can see the walls here. If you don't like the width that I selected, you can increase that, you can decrease that. That's up to the guy who is doing the 3D animation. So you see the walls here. So the walls are added and it's looking really nice. Okay. After that, we can add some trees. The trees are a little bit different. They are a point layer. Well, you can see that we have a lot of trees in this project, and I just added some trees, not all trees, because then the processing of this 3D would take like forever for this webinar. So I just picked some of them just to show you how you do this, okay? So this is a point layer. You can do this on your own. Just create the shape file and add some points. So to add the 3D object, right click on trees, properties, 3D view, single symbol, and then on the shape here, you have to select 3D model. Then you click here and go where you downloaded your 3D model. In my case is this apple tree, and select the .obj here. Once you select that, just keep everything the same, click OK, and then you'll see that the trees were added to your project. They don't look nice. They are this bright green, looking weird here. We can change that. If you go here to properties again and use this realistic font here, I like to select dark green, something like this is okay. And you just click OK again, and then they look better. Let's wait for them to load. Yeah, they look a little bit better. Let's see. So yeah, you can play with that. It depends on the quality of your 3D object, but this is how it is looking like. Okay, good. So we created a QGIS project. We loaded the domain. We added the Google Satellite. We downloaded the OSM data. We set the buildings level. We created the 3D. We added some 3D details. And this is looking good. What I'm going to do here, I'm just going to save this project. Let's go back here. Now let's add some FLO-2D results. Let me go back here. Let me zoom out a little bit. And to add the FLO-2D results, I'm going to use MapCrafter. Uh, we need to select. So inside this folder here, we have a FLO-2D simulation with the results. You just select the folder. It is just a flooding simulation. And I'm going to select the maximum depth, some velocity vectors, channel, and the maximum channel depth. And I'm going to create the maps. It takes some time. When it's done, it's done. I'm going to move this a little bit behind here. And then we have the maximum depth and maximum channel depth here. What I like to do on the symbology of this raster here, I like to go to properties, and this is the minimum is 0.001. So this is in feet. So I would like to use 0.1 feet. And after that, I want to clip all those small depth values, okay? Click OK. So you see that we have the results here. The maximum depth and the maximum channel depth, they are using different scales. So I would going to, since this one here goes all the way up to 9.5, I'm going to copy this style here and paste on the channel so they are showing the same data, same color data. And we can add the velocity vectors if we want. You see, um, I'm not going to add the velocity vectors because it takes a while to process. So, but just add the data if you have time, just run it with the velocity vectors and they will show you the direction of the flow. It's really nice to have this in your 3D animation, but I'm not going to do that. Okay. Let me zoom out a little bit here. Let's see. So I added the depth and velocity vectors, which I'm not going to use. After that, I need to create the 3D view. Okay. So what we have here, we have walls, we have the trees, we have the buildings, we have the results. Everything is looking good. What I like to do here, in general, you don't need to change anything here on the terrain. You need to add your DEM. You can add like an online DEM. It is not so good, but sometimes it is better if you don't have any DEM. I like to add some lights. Usually I do like 30 here and something like this. So on this side here, you can see that are the shadows. And if we go to the other side here, we can see that we have the sun on this side, the light on this side here. Okay, so yeah, I like these results here. It's okay. What else do I need? Okay, terrain lights. Okay, now the keyframes. So this is something that looks a little bit complicated the first time that you do this, but it is not that complicated, okay? So to create the animation, you need to use these animations here. Just click and you are going to get this toolbar on the bottom. First, delete the 5 seconds. Delete this guy here. Go to 0. So this is where your video is going to start, okay? It's going to start at this point here. What you need to do, well, I'm doing something that I like. You can choose whatever you want. You can choose 5 seconds, 10 seconds. That's up to you. I like to do this between at every 3 seconds. So I add another keyframe at 3 seconds. This means that from this position, that is the 0 seconds, up to 3 seconds, it's going to be on this position here. That's going to make more sense when I run the animation. The next keyframe is going to be 6 seconds, which I'm going to do some zoom here. Let's say something like this. The next one is going to be 9 seconds. Then I'm going all the way up here. Let's say something like this. I think it's cool. Then at 12 seconds, I can zoom in a little bit here. Something like this. 15 seconds, I can go over a little bit here. 18 seconds, I'm going to zoom out and I'm going to this corner here. Let me zoom in a little bit here. 21 seconds. Oops. And then here at 24 seconds, I'm going to do something like this here. At 27 seconds. And I'm going to end this at 30 seconds. Let's say something like this at 30 seconds. So this is how the animation is going to look like. So the interpolation is really important. This is a linear interpolation, and I don't like that. It's like, I don't know, it looks weird for me. So what I'm going to do, I'm going to stop this, go all the way down. And I really like to use the in-out cubic interpolation. For me, this is the best one, but you can choose the one that you like. So just click here. You see that it has this effect starting slow, going fast, and slowing down again. So that's the interpolation. And this is how the 3D is going to look. You can see that we see the FLO-2D results on those 2 points here. Some flooding inside the city. The trees gives a nice effect. If you add more stuff like some recycle bins or anything else you can add, it looks really nice. Okay, so this is how the animation is going to look like. After that, we need to export the frames. To do that, just click on export animation frames. This is the template. It's going to export some screenshots at every time based on the frames per second that you select. So first select an output folder. I'm going to create one. I truly recommend you to create a folder just for that, called animation. Select the folder. I like to use 60 frames per second. Since my screen here is a widescreen one, I'm going to use 1920 pixels per 1080 pixels. And I'm going to click OK. And then QGIS is going to start exporting the frames for us. If you go to the folder that I just created here, you are going to see that we are going to have a lot of images based on the animation that we just created here. So this is going to take, I would say, like probably 3 minutes or some. So if you have any questions, I can ask those questions right now. Let me see if we have any questions. So we don't have any questions. So while this is exporting, I'm going to talk about some final remarks here about the importance of using a 3D simulation like this to present your results. So especially in urban areas, this animation can be a powerful tool because they can enhance the communication, the planning, and community engagement related to the flood risks and management. So if we look into the public outreach and education, people can learn more about flood safety measures. We can engage community by visualizing potential flood scenarios and understand their risk. This means that people will know which road is going to be flooded, um, stuff like that. So it's really nice. They can see it's better than showing them tables or graphs. Seeing this, or even maps, seeing a 3D animation is better for people to understand where the flood is happening. This can also aid in urban planning, because it can show to people areas that are prone to flooding, and they can also assess the impact of new developments on local drainage and flood risks. For emergency management and response training, we can present the visual evidence of where the risk is, where and what potential solution they can find, like in terms of routes to um, move people around. We can also train first responders and emergency management personnel using those realistic simulations in order to improve their preparedness and response strategies during those flood events. And finally, some community resilience building where we can foster collaboration amongst stakeholders, local governments, NGOs, residents, by using those animations to visualize shared risks and collective action plans. Okay, I hope that it finished. Yeah, it finished exported. So we have this huge folder here containing, I don't know how many, 1,800 files here. And now is where we use FFmpeg. There are other software that can create animations from screenshots. I'm using FFmpeg because it's free and it's easy to use. Um, it uses a command prompt to create the the animation, but it's not rocket science. Just open a command prompt here. Let me just go back here to the code. And it's a really nice code. Um, if you have FFmpeg installed, you just type FFmpeg. You see that you have it installed. So I did not create the simulation at this, the animation at this time. I'm just showing you that if you type that, you get this message here. You can see that FFmpeg is installed in your machine. So to create the animation, you just need to type FFmpeg, then the frame rate that we are going to use, which is 60-I. Then you need to type what's the name of the file here. So this is 3D-project, and that's where we have the counter using um, four decimal places. So basically, this is going to be 3D project. Let's just double check that project. Yeah. And then you need to type this code here, which is this symbol 04, four decimals, d dot JPEG, because I'm saving this as JPEGs. And then the name of your animation. We can call this animation dot MP4. You can save that as an AVI file, but I truly recommend MP4 because it looks better. Okay, just type enter, and then you can see that FFmpeg is processing your screenshots, and it's going to give you 6-7 seconds. So we did 30 seconds. You can do more, you can do less, depending on the size of your project. We did for some huge projects and it worked really, really nice. Um, the more 3D features you have, the more 3D models that you added, the bigger your computational domain, the bigger the data that you downloaded from OSM, the more processing will be required to create animation and working on the 3D map view here on QGIS. This is something that was recently added, if I'm not wrong. So there are some stuff there. It's going to be added probably in the next month of or years. So let's get back here. So we have everything. This animation is going to be saved in the same folder. And here is the animation that we just created. Double click and you will see the animation here. So we see that the color is a little bit different, but we can see the flow to the results. We can see the walls. We can see the trees, and the trees has the shadow based on the light that we added to the animation. So we have more light here, and this is what we just created. Okay. This is the what I planning to show on the webinar here. I just want to show one little thing before I go to the questions, is that if you want to use a larger area and this makes sense, uh, it's nice to show not only a very small portion of your project. So you can just use, as I said, a larger elevation file. So let me just show you. So this is a larger elevation that covers almost the whole city. Um, and instead of using that elevation, you can select this elevation larger here, click OK. Wait a little bit. I'll probably need to close this and create a new one. Yeah. So then you have an effect that you're seeing like the whole world, something like that. But you see that this elevation data that I'm using here is not good. So I can barely see the canal here. So yeah, this is something that you have to think about if you want to use a more precise elevation data or a less precise, but where you have a larger area here. So yeah, this is something that can be done because it's nice to have this information around your computational domain here. Okay, so let me see if I have anything else here. No, the final remarks I already talked about. So if you have any questions, any suggestions, I'll be really happy to answer here.